Hello everyone. In this particular video, we will explore a very simple but beautiful problem in probability theory. Let's look at the problem. It says that we have a 6-digit number which is chosen at random. So I'll talk more about this word random, which appears randomly in probability theory. I'll come back to it. Now the question is, what is the probability that at least 2 consecutive digits in the chosen number are equal? At least 2 consecutive digits in the chosen number are equal. For example, the number could be like this: 225314. It's a 6-digit number. 2 of the numbers, the chosen numbers, are equal. It says at least 2 chosen numbers or 2 consecutive numbers are equal. So there could be more than 2. For example, we could have 235551. That is also example of a kind of number which fits into this category. At least 2 consecutive digits are equal. Okay. So let's see how we can work with problems like this at the conceptual level. So I will give you a strategy that you can use to solve these problems. But I will also give you a challenge problem. If you can solve it, put it in the comment section. The best commenter is usually awarded every month. Okay? Alright, so let's look at this. The first thing is, we have to calculate all the 6-digit numbers that are there. How many 6-digit numbers are possible? Of course, the largest 6-digit number is comprised of 6 nines, 999, 999, and the largest 5-digit number is just this. So if you subtract these two, you will get the number of 6-digit numbers. Here is a challenge question. It's a very simple challenge question. Can you give me another way of counting? Another way of counting all 6-digit numbers. All 6-digit numbers. So we have 900,000 6-digit numbers. Now we have to figure out how many of those numbers, what proportion of those numbers have this property that 2 or more consecutive digits are equal. 2 or more consecutive digits are equal. So here comes the strategy. This strategy is sometimes called the method of complements. Well, it's quite hard to actually calculate the number of numbers such that 2 consecutive digits are equal. You have to check case by case. It can be done, but you have to check case by case. For example, maybe you can divide it like this, that exactly 2 consecutive digits are equal. Exactly 3 consecutive digits are equal, and so on and so forth. These will be mutually exclusive cases, and you can probably count it. But an easier way would be to calculate the other numbers. That means the numbers which do not have these properties. So that means numbers where no 2 consecutive digits are equal. Okay, no 2. So those are the other numbers. We can calculate these and then we can subtract those many numbers from all of them. Whatever remains will have this property that 2 or more consecutive digits are equal, right? This is a clever one. So let's start with that. No two consecutive digits are equal. So how many choices do we have for the first slot? Well, 9 choices, because first slot cannot have the digit 0, but it can have all the other 9 digits, 1 to 9. Let's look at the second slot. How many choices do we have? Well, now we have 10 digits, but remember, we cannot repeat the digit that we used here. So we cannot repeat this particular one. So out of the 10, 1 is gone. So we really have 9 choices for the second slot. Let's look at the third slot. Again, the same argument flows. You have 10 digits, 0 to 9, but you cannot use the digit that is used here. So one of them is gone. So you have 9 choices left. So at every step, you have 9 choices left. So total, you have 9 to the power 6 numbers with this property that no two consecutive digits are equal. Okay? So now comes the word random. What does random mean? Now listen to this very carefully, because this is a conceptual point. What probability does is that it takes a set of numbers, A, B, C, D, a set of objects, let's not call them numbers, a set of objects, and in the discrete case, in the continuous case, I will probably talk about in a different video, but in the discrete case, what it does is that it assigns some number, maybe 0.1, maybe 0.3, maybe 0.5, some number between 0 and 1 to each of these values, to each of these elements. So it is a function, probability is a function that assigns numbers to each of the elements in this space S. Okay, so you take an element in the space S. What the probability function will do, it will take that element as an input and give you a number between 0 and 1 as an output. There is one more condition. If you add up all of these numbers, all of the outputs, it should be 1. If you add up all of the outputs of the singleton elements, the sum should be 1. 1 means everything. So secretly, at a conceptual level, a probability is a function that takes input as elements of this set and gives output as numbers between 0 and 1, and that those numbers should add up to 1. Those output values should add up to 1. Now, where is the word random coming in? Random means there is nothing random about random. Random means each of these output values are actually the same. They are equal. I'll give you an example. Let's look at an experiment of tossing 2 coins. If you have 2 coins and you are tossing them, let's create this set S. So what are the different cases? You could have head, that's one case. Head, tail, that's another case. Tails, head, that's another case. And head, that's another case. So you have 4 things that can happen to those if you toss 2 coins. Now, what you could do, and this can very well be possible, you could say, okay, the probability function assigns the value 0.1 to this, 0.1 to this, 0.1 to this, and 0.7 to this. That's a perfectly normal probability distribution. Probability function. That's totally fine. When I say there is randomness. That means all of these outcomes, all of these output values are actually equal. So all of them are 0.25. That's all that it means. So in the case of this particular problem, you have 900,000 numbers. So the set contains, so your set S contains choice of 100,000. That's a 6-digit number. Your set contains choice of 352911. That's another choice, right? There are 900,000 choices. 900,000 choices, which makes the particular set S. And each of them produce the same output. They have the same probability. That's what it means when I say pick a number at random. Mathematically speaking, that's what's happening. So you are assigning the same weight, let's call it X, assigning the same weight to each of these output possibilities. And how many output possibilities are there? There are 900,000 of them. So if you add them up, you will get 900,000 X. And we know that if we add all the probabilities, if we add all the output values, I should get 1, right? So X is 1 by 900,000. That's the value. So that's, colloquially speaking, that's the probability of each outcome. But I hope you understand at the conceptual level what's happening, right? Okay, now let's come back to this problem. It's a very simple problem. We now know that it is the probability of getting no two consecutive digits are equal. Those type of numbers is 9 to the power 6 divided by total number of cases, which is 9 times 10 to the power 5. That means the case that we actually want, where either two of them are two consecutive numbers are repeated or 3 consecutive numbers are repeated and so on, that is 1 minus this particular thing. 1 is everything minus the probability of that thing not happening, right? So this is called the method of complements. I hope you enjoyed this video. If you did, please like and subscribe. Thank you for joining us today. I'll see you in the next one.